So before we get started, I wanted to give you a quick introduction to S28. S28 is a company that's been around for about 8 years, and we have 4 practice areas. One of those areas is around full product development lifecycle capabilities, from requirements to design to long-term sustenance and support. We also conduct work in terms of Oracle implementation and upgrades. We do IBM Optum information lifecycle management, and we also have a practice around big data, data management, and data analytics. Within the product engineering services, we do everything from mobile development for both Android as well as iPhone. We've also done numerous product integrations, application integrations with Oracle as well as other products. So moving on through to the integration offerings, we have had over 150 successful integrations, and with those, what we're seeing is a big demand for integrating cloud and on-premise. The demand we're seeing is a lot of companies that we're working with today have a lot of their data and applications on-site, on-premise, and they're looking at the cloud and looking at SaaS applications as a means of enhancing what they're doing on a day-to-day basis. But the big challenge is, how do you create an integrated view to a user when some applications are on the cloud, some are hosted as software as a service, and others are on-premise. So we have a lot of expertise in being able to achieve market-leading integration using either open source tools or using our own technologies, as well as commercial tools. So if you can see from our client list, we have quite an impressive list of clients, everyone from Cisco to IBM, Stanford University, SRI, and with the majority of our clients, we're doing work that is broad-based, meaning it's everything from strategy and architecture to implementation and support and maintenance. So we have a great track record, and we're 100% referenceable across the client base. So why is S28 successful? We grew 65% last year. We have an extreme service culture. We're a small company, and as a small company, we're extremely responsive to our clients. We have a delivery team in the U.S. as well as a support team in India. Half of our 300-person team is in the U.S., and we're 100% referenceable, as I said. And we've worked on everything from large to small organizations, and taken responsibility for deliverables at those companies. So let's get into the meat of the discussion around quality engineering. So what we've seen in terms of a trend in the market is we've seen a trend of higher emphasis on quality, secure, reliable software. We've seen a trend on more and more cloud-based software, and essentially software companies becoming services companies. And what I mean by that is software companies have become service providers and using software that they develop to provide a service to their clientele. This is a very, very important trend in the industry, because it really puts huge emphasis on quality. And whereas in the old days, before the cloud and before software as a service, you could get away with on-premise software and releasing software that maybe had a few bugs. Today, there's no tolerance, because once you put out a release, that release has got to work, and there's just no tolerance for an issue and rolling back, for example, a release, or rolling back an upgrade. So emphasis of quality is very important. The impact of quality engineering is huge. So as most of you have heard, when you find an issue in the wild, meaning that after the product's been released, it can cost anywhere from 10 times to 100 times more to fix that issue than if it's caught early in the development cycle. So if you have a quality engineering-centric development organization, you're catching issues early on in the cycle, and you're looking at overall technology and process to ensure that issues are caught early, that they don't get to a point where they're extremely expensive to resolve. So you've all seen this time, cost, scope triangle, and quality is certainly at the center of that whole triangle. So I'm sure anyone that's been in a development situation, product development situation, has been pushed to trade off time, cost, and scope, and that has affected quality. And those trade-offs in many cases are false trade-offs, because if you compress time, as an example, you're going to pay for that at some point later. And actually the time that you dedicate to a particular product release or a point release is going to increase as a result. So, and you're going to end up with unhappy customers. So there might be a short-term view towards, hey, we got to get that release out. We promised it to our customers, or we got to get a certain feature out. We promised it to an individual. But in the long term, the payback for that kind of a short-sighted view is huge. In a quality-centric culture, the quality engineer can stop the production line. And I'm using a manufacturing analogy here because it's a good visual. So when you have a quality engineering-centric culture, a quality engineer looks at not just the end product, but looks at the overall end-to-end solution that has been developed, and looks at the processes, looks at the technology, looks at how development is working, and is able to take preemptive actions to ensure that there's no long-term issues in the product. So the quality of the product isn't just about the product, it's also about the processes and the technology that's used. And this one key takeaway that should come out of this presentation is that we're not just talking about doing better QA or QA automation. We're not just talking about more test cases. We're talking about a quality-centric view, everything from requirements gathering to requirements traceability to design to the final development of the product. And actually the skills of the engineers developing that product is extremely important. So for quality engineering, I have stolen something from CMMI, and I think that this will resonate for those of you that are familiar with CMMI and capability maturity model, Carnegie Mellon capability maturity model. For those of you that are familiar with that, this is a good way to embark on the journey of quality. So we view quality based on a process perspective and as well as a technology perspective. And we view that it's not a good idea to jump into this too aggressively, that you need to take small incremental steps to get where you need. So what we've done at S28 is we've developed a quality engineering maturity level model. And you can see that you can assess, or you can use an outside firm to assess where you are in terms of your QAML. And it's important to be honest with yourself what that QAML level is. Once you've done that assessment, then you can set incremental goals over time to improve your quality and to create a culture of quality. And that takes buy-in from all levels of management. It's not just the development organization. It could also encompass the marketing and sales organization, because they're the ones making commitments on behalf of development. And once you have that, then you can truly embark on the journey towards end-to-end quality. So with QAML assessment, you should assess your QAML from two perspectives. One is process and the other is technology. And then you can rank differently on the QAML scale. For example, you could have excellent development processes, but your technology is old and inflexible. So then you really need to improve on your technology. Likewise, you can have your application built on a very, very modern framework, but because you're a young fledgling startup, your processes are immature. So again, it's good to get a third-party perspective. That could be a company like Estuate, or it could be somebody that you know in the industry that maybe has been around for a while and is able to better assess where you are on the QAML scale. Once you've done an honest assessment, then you can set QAML goals. And the goals should have the buy-in of everyone in the organization, as I stated. And that goal could be a simple business goal. For example, not having severity 3 defects in releases, or not having issues around, or certain levels, target levels of number of issues in a particular release. So with technology and process QE, a lot of folks that I've spoken to about this and the challenges around this is they've used the analogy. It's like changing the tires on your car while driving down the highway. So it is very difficult to do that. I mean, you're especially if you're a young company, you're trying to put out releases, satisfy your customer base, trying to meet sales commitments, but at the same time, you're trying to achieve these quality standards. So it's important to make reasonable challenges to your organization when you're doing that, and keep the lights on, because if you go too far in one direction, you could shock your organization's ability, and that could be disastrous for your organization. So the process that we suggest for doing this is looking at process QE first, and then technology QE second. So step one is look at how you can improve process QE, for example, from a level 2 to a level 4, and then achieving improvements in technology QE from, say level 2 to level 3. Now this is just one example. It could be the converse of this. It could be the opposite, depending on where you are as an organization. And so it's not recommended you do both process QE improvements and technology QE improvements at the same time. So the key word here is incremental. A big bang approach to process QE could be too daunting, or a technology big bang approach could be too daunting. So you need to take incremental approaches, and again, having an integrated holistic process to quality engineering that everybody will buy into. With process QE, you can look at various, and a lot of this is stolen from agile development. I'm sure those of you that are familiar with agile have seen these principles. For example, developing use cases and test cases early in the development cycle, requirements traceability to test cases, comprehensive unit tests, doing peer reviews, testing early. These are all agile principles. And if you're familiar with agile, you may already be on the way towards doing this. Requirements traceability is extremely important, because if requirements change as the product is being developed, then you need to change your test cases accordingly. And process QE emphasizes that. It's important to update that business documentation so everybody's on the same page with regards to what kind of tests are required and what are the acceptance criteria for those tests. Likewise, defect analysis is extremely important. So once the product is released, and even with an organization that has good quality processes and good technology around quality around their technology, there's still going to be issues. And some of those issues could be in clusters around the product. So for example, the API of the product could be problematic, and there could be issues around the quality of the API and just how well the API supports integration. Another issue could be around the performance of the application, and so these have to be pointed to a root cause and clusters of defects around the root cause. And developers should investigate those issues to understand why they're occurring and use advanced techniques. You may have heard of Taguchi methodology, using advanced techniques to be able to better determine the root cause of the issues and be able to eliminate clusters of defects. With process QE, as I mentioned, an agile approach is recommended, and we've had extremely good success with agile because it has an emphasis on small bites, smaller teams, accountability, and close collaboration across all disciplines. I think it's also important within agile to build it simply the first time, meaning if you take on too much scope, then that only adds more complexity and will detract from the user experience. And we've seen where applications get delivered with a lot of complexity, and folks feel that the application usability is sacrificed as a result of the complexity of the application. So a lot of quality has to do with what we would call more soft quality measures, and those soft quality measures are around performance, scalability, reliability, and availability. So if your product, say has a very appealing UI, great functionality, but it doesn't perform, or it doesn't scale, or there's some security issues with it, then everything falls apart. So performance testing is sometimes is an afterthought to a number of organizations, and I think it needs to be part of your whole technology strategy when you're developing products. Likewise, documenting what the product can and can't do is extremely important, and reporting on those metrics, and that provides a feedback mechanism. And if we go back to the QAML triangle, you'll see at the topmost level that there's a feedback loop. When you're at a level 5, there's a feedback loop that gives you feedback into the overall development process to understand what's working and what isn't working. And that feedback is used through metrics around deliverables and metrics around development processes, so you can have a better determination on what is working in the organization and what is not. We also recommend using a real-time dashboard, and that real-time dashboard provides total transparency on the release as well. So here are a couple of QAML goals. So requirements traceability, I talked about that. So if you've committed certain requirements, and those requirements are going to be high quality, having test cases and requirements traceability and documentation around those is extremely important. Instituting a culture of quality is also, it's not just about process and technology, it's also about people. And people, engineers, the whole team needs to band together with a view on quality. And when you have a view on quality, then it's easier to catch bugs early because people have a focus on doing that. And lastly, the incremental approach, and that again falls back into agile. So you've got frequent stakeholder involvement. You might even get a lighthouse customer, somebody that you can trust with your alpha release to give you some feedback on what's going on. So when you have QAML process goals, you have to decide what are the perceived business case benefits? Because at the end of the day, you need to talk to the CEO, you need to talk to VP of Sales, and educate them on why you're embarking on the QE journey. and put it in terms of a business case. And the business case could be increased customer satisfaction. It could be better product quality, less cost for doing product development, because obviously where there's a number of sometimes contradictory factors in achieving a product release, and so having full backing of the whole organization with an expected ROI is very, very important. So moving on to technology quality engineering. With technology quality engineering, we're looking at, is the product written in a more modern technology? For example, is it a services architecture? Is it built for on-premise and needs to be developed for the cloud? How can you afford rewriting legacy applications to leverage the latest thinking in architecture and technology? So those are questions, and I mentioned the changing the engine in your car while driving down the highway, or tires on your car. So you can't do this. It has to be done incrementally. So you need to do this in a staged approach. Just shutting down the company for 6 months or a year to retool just doesn't work for most companies. Also, the skills for building a quality product, a lot of time the limitation factors around the skills of the resources that you have available to do the work. So for example, if you're embarking on SOA, a service-oriented architecture, and folks don't have a lot of experience with that, then you need to hire folks, or you need to put folks on training programs. One challenge that we've seen in software development is design complexity. So you try to build an architecture or a design that does everything, or you try to solve problems for the next 10 years. So these are some of the principles that we've identified to keep things as simple as possible. And when things are kept simple, then it becomes a lot more easier to catch issues. Really thinking about architecture and thinking about design is extremely important before you start going. And as the cartoon says, enough of this design stuff, we're behind schedule, let's start quoting. Well, that's obviously the wrong approach. You need to really think through what you're trying to achieve before you embark on that journey. What some of the factors that we've seen with technology issues and decisions that have been made. For example, poor usability and interactivity. The UI of your product is the face of your product. And if that face of your product is poorly designed, no matter how good the functionality is or some of the other aspects of performance and scalability and security are, if the face of the product is poorly designed, no one's going to use it. You're going to have poor acceptance of the product. And some of the most dismal failures that I've seen with product is we've released a product with no defects, but nobody uses it. And nobody uses it because there's low user adoption, and part of that could be because of poor usability and interactivity. Also need to understand how the product is used so that click-through flows and there's an understanding so that it's easy and intuitive for somebody to use, taking into consideration casual users versus power users, and understanding for the user to have an understanding of the product without having to open up a manual to figure out how to use the product. Maintainability is sometimes an afterthought. So, people develop the product, it's released, and then support team has to sit there and have field issues that customers have that get called in. So poor maintainability sometimes can be around memory usage, could be around data access issues, could be various flaws in the design that make it very difficult to maintain the product. And poor maintainability, some of the repercussions of that are having essentially burning out your support team. So you have a support team that's constantly fighting battles on issues. Poor maintainability can also result in unhappy customers because they're always dealing with particular issues, maybe around a data load or something else. And if you have poor maintainability and problems with bug fixes and improvements in future releases, it just gives customers a bad taste, or the users, for that matter, a bad taste around the product. So I talked a little bit about technology and extensibility earlier in this webinar, and what happens is a company will develop a product, and then over the years their business model changes, or some things that they did not consider should be in the product have to go into the product, and that causes undue amount of stress on the existing architecture. So this is where redesigning the product might have, a point in time might have to come where you redesign the product so that it can be extensible, so that you have a long-term, multi-year view of the product as opposed to just a project view, a short-term release. Security is huge today. I'm sure every day in the news you hear about folks that are hacking into folks getting in behind firewalls and hacking into systems and getting personal data. So doing a full security assessment of the product and looking at designs to ensure that they are secure is very important. So here are some QAML technology goals. These are just samples. It could be different depending on your organization. So response time. So for example, if a user clicks on a particular icon in the UI and that icon doesn't respond for 15 seconds, that could be considered broken. So have particular goals or have particular documentation around how long it should take to do various actions. Look at how your product or how your application fits into the custom ecosystem. So that's also an important aspect. Integration, especially in this day of cloud and on-premise and SaaS, how it fits into the overall ecosystem is very important. I talked about security and extensibility around new functionality. So as your product evolves, how easy is it to extend the API and bring in new functionality? So when you look at technology, don't look at technology just from the standpoint of, well, it needs to be the latest and greatest, in Java, C# or whatever, or it needs to be written in Perl. Look at the business goals and what's your expected ROI. And that way you can sell it to the CEO, you can sell it to the VP of sales and those folks and explain why we're making investments in that direction. When you're doing QAML planning, it should be sequential and iterative. So look at metrics, look at where the problem areas are, and as again, do a full assessment to understand where you need to be with regards to the goals. So in conclusion, this QE, quality engineering, isn't just about quality of the product, it's a culture of quality. And for that, I think if we steal some learnings from the manufacturing industry, in the software industry, I think we'd be much further ahead. And so a culture of quality, and if you look at developing software in manufacturing terms, you'll see that culture of quality is critical across the entire company, not just the R&D organization. And that would include training programs, that would include organizational development for the folks, and also not contradicting that culture of quality with death march releases where folks say, well, management might say quality is important, but then we go on these death march releases and have to release poor quality, and then you have infighting between professional services and the development organization, and end up with a lot of issues. And finally, with a higher culture of quality, it pays huge dividends in terms of higher customer satisfaction, greater ability to meet market needs, and a healthier company in the end. Thank you. And this concludes the webinar. I'm ready to take questions.
Great. Thanks, Roger, for presenting. Now we'll open it up to questions. Please go ahead and type in your questions in the question area to go to webinar, and we'll get them answered. Roger, do you have a contact slide you can flash up?
I'm sorry, I do not. No.
Where can they reach you at? Let me just, I can read off your email address. I have it right here, actually. Roger's email address, should you want to contact him, is roger.nessier. That's spelled N-E-S-S-I-E-R @s28.com. Okay, here's our first question, Roger. How do you balance release commitment dates against quality? Should we release on a committed date regardless of where we are in the testing cycle? You touched on this during the webinar, but go ahead and take this question.
Thank you, Mike. So release dates are a very, it's a topic very close to my heart, because what happens when you release a product, especially if it's a cloud-based product or software as a service, when you release that product and it's not at the quality level that it needs to be, you immediately get a response from customers, and that response can be very negative, and that can reflect very poorly on the organization. So I'm a firm proponent that if the release is not up to snuff, that you take the bullet at that juncture, as opposed to releasing it and then hoping that your customers won't notice that there's issues in the product. Now, the alternative, which is not as good, is if you release the product early to alert your customers that it is a beta release, or that you are aware of these known issues, so that customers don't feel that you're just releasing something for the sake of releasing it to meet a timeline.
Okay, great. Thank you, Roger. Next question. Why aren't more companies taking a QE approach to development if the end value of a QE product or solution is so much better?
I think that the market and the pressures in the corporate world are huge to deliver. And I think a lot of the folks in the business roles in companies don't realize, in many cases, how complex it is to deliver software. So you end up in situations where commitments are made by the sales organization or even the CEO, and rather than essentially say that we're not going to make those commitments, something gets released, but it's not what the CEO or the sales team said was going to get released. So it essentially, you end up delaying the inevitable. So that's why I really emphasized early on in the webinar the importance of having full buy-in from the organization around a QE program. For example, if the CEO and the VP of sales say, you know what, we don't really buy this QE program, it's not going to be successful. You need to have full buy-in in the organization. I think just embarking on it on your own in development or a quality organization is essentially a recipe for disaster.
Okay, great. Thank you, Roger. There are no more questions. We've recorded this webinar, so we'll be putting it up on S28's website in a couple of days. You should see it there should you want to invite your friends and colleagues to take a look at this webinar. Roger, thank you for presenting very much. We really enjoyed it. It was very informative. And like I said, we'll put this up on the S28 webinar, or I'm sorry, S28 website, and their contact information, your email address on the screen, should anybody want to contact you. Again, thank you, Roger, for presenting today, and thank you to the attendees for attending. Have a great day.
Thank you, Mike, and thanks for organizing it. Thanks, everybody, for attending. Bye-bye.
Bye-bye.